Live. It would be a quick one. Okay, first we'll start talking to ourselves just to check the sound and everything. Okay, so we have a Claude 3.7 Sonnet thinking model. Let's read this out loud quickly.
The code looks technically correct. It implements principal component analysis, PCA, using the Jacobi SVD algorithm for computing eigenfaces from images. Here's what the code does. Implements the Jacobi SVD algorithm for eigenvalue decomposition. Computes the mean face from the input images. Centers the faces by subtracting the mean. Forms a smaller covariance matrix, number images times number images, which is more efficient than using the full pixel dimensions. Applies SVD via the Jacobi method to the covariance matrix. Sorts eigenvalues and transforms eigenvectors into eigenfaces. Normalizes the eigenfaces and returns them along with the mean face. This approach is efficient because it works with the smaller dimension, number of images, rather than the larger dimension, number of pixels, which is common in PCA for image data. The implementation appears mathematically sound and should work correctly for eigenface computation.
Okay, what do you see on the screen?
I see a web page titled Eigenfaces, with some text, slider bars, and an image of a person's face. There are also 5 images above that look like ghostly faces. Do you want to know more?
Yeah, what's happening now?
The dot on the Eigenface 1 slider is being moved to the right. Is there something specific you would like me to observe?
Yeah, what's happening to the image below the sliders?
As the slider for Eigenface 1 is moved to the right, the image below the sliders starts to have its features become more pronounced. The highlights get brighter and shadows get darker.
How about now?
The Eigenface 2 slider is being moved to the right now. Is there anything specific about this change that you'd like me to comment on?
Yeah, how about now? What's happening to the image below the slider? So I'm moving eigenphase 3, and what's happening to the face below? Can you try and guess what it is all about?
Okay, the slider for Eigenface 3 is being moved to the right. The image of the face below becomes darker, and the nose and lips are more pronounced. As for what the sliders are about, it looks like each one corresponds to a different feature of the face, and when they are adjusted, these features are altered in the image of the face below. Does that seem right?
Yeah, that is correct.
Okay, now the Eigenface 5 slider is being moved to the right. The image of the face below now looks more like a negative image. Is there anything specific you'd like me to observe about this?
Do you know why the image is so low resolution? I was originally recording my camera footage with much higher resolution.
Based on the text at the top of the page, it seems that the eigenfaces displayed are the principal components extracted from the captured faces, meaning that they're not intended to be full resolution images. When you click Capture Face, the full resolution image is shown in the Captured Image window. Does that make sense?
Yes, can you have a look at it now? Like when I capture the face, the image is much smaller. We actually have another developer doing the code for us, so we need instructions for them to fix the code. What would you improve about this web application?
Okay, I see that the captured image is much smaller than the camera input image. Also, as you adjust the eigenface sliders, the image at the bottom changes, but it remains low resolution. I would suggest keeping the resolution of the captured image and the adjustable image consistent with the camera input. Is that the kind of feedback you were looking for?
Yes, it might be. How much more computationally intensive that would be?
I understand. You're suggesting that processing and displaying higher resolution images may be more computationally intensive. Is there anything else I can help you with regarding this web application?
Now that's fine. That's pretty good as it is. Okay, so we're calculating eigenvectors. We have another JavaScript code for that. Okay, I'll just go into the chat. Okay, so we have, which one should we use? Let's use all three mini quickly. Okay, if you can, just a few questions about the code. First of all, how many captured images is the maximum? There seem to be, once we crossed a certain number, we seem to be getting like an error on the screen, but it just flashed briefly and I can't actually see what it is. There's no errors in the console. Oh wait, there are errors in the console.
The code doesn't enforce a strict maximum number of captured images. Every time you capture an image, the code adds it to the face images array, and, if there are 2 or more, it triggers the eigenface computation using all of them. The error you're noticing may be happening in the SVD/eigenface computation. Like,
Okay, but still getting. We're still getting a few errors. Someone's asking, can you do LabVIEW again? Yeah, we can. Yeah, we can. If you pay for the license. The license is very, very, very extremely expensive. Can you do LabVIEW again? Yeah, we always have a special space in our heart for LabVIEW. The other thing, I don't think you can do AI in LabVIEW. Yeah, if you had chatbots, why do you use LabVIEW? You obviously use it because you have a specific hardware. I have some hardware sitting around, but it's pretty old. I think the company got acquired or something. So, but yeah, if any of these AI models can do LabVIEW, I'm not sure they can. We're actually trying to replace LabVIEW. We actually have a thing. Oh, I forgot. It was a while back. That meant to actually replace LabVIEW. And it's actually working pretty well. So, and I lost it. And obviously searching for LabVIEW. No. This is the programming. Yeah, the search is useless. Modeling, no. Data analysis, no. Anyway, I lost it. Simulations. Yeah, if you can find it for me, that would be great. But yeah, it was like essentially a LabVIEW replacement. I forget what it's called. Some graphic. There was a Python. Converting graphical programming into Python something. Can search for it. Anyway, lost it. I think we lost the viewer as well. Is it Dicky Rahadian? Anyway, I can find it. It was just a mock-up. Didn't have an image, didn't have a thumbnail. Seizure, EG, Gate, Cardio Rock Puzzle, Flowchart, this one. Yeah, this is your LabVIEW. I don't know if Dicky is still around, but we got our own LabVIEW inside the JavaScript. All the code is on the page. You can add an input. And do that kind of stuff. The stuff that you can do in LabVIEW. And the good thing about it, if you refresh the page, that it will generate Python code for you. So for example, yeah, it's not complete, obviously, meant to be able to somehow, it's not great, but it's there. So essentially, no, because of the license cost, we are not doing LabVIEW anymore, and because it doesn't have AI capabilities, I don't think. I'm pretty sure someone will argue otherwise, but we're not having this argument. It's just so for simplicity reasons, the license cost. And I guess you will only use LabVIEW if you have the National Instruments hardware, which is again super expensive. I have an older version of something, but I'm not sure if it's of any interest anymore, as opposed to PCA analysis. So PCA analysis is much more interesting. Trust me, I'm an engineer. And we have this mockup, so we're doing different facial expressions. It's setting it as an eigenvector, and we essentially can change the features of that expression. So that should be the first or the last. Yeah, would be that one. Yeah, we don't really need Claude anymore because we have it within IDE, within the development suite. Okay, we are live streaming at the moment. Are you happy to live stream together? Just a quick responses. Hey, can you act as a 21-year-old with a Eastern European accent?
Sure, I can do that for you. How can I help you today? Let me know if there is anything specific you'd like me to answer.
Okay, just short responses, no fluff. If you feel like being funny, go for it.
All right, got it. Quick and to the point. What's your question?
Well, we're live streaming together, so you can be addressing the viewers directly. Have you ever heard of LabVIEW?
Yeah, I'm familiar with LabVIEW. It's a system design platform and development environment from National Instruments. What do you want to know about it?
Which one I should be using, Python or LabVIEW?
It depends on your needs. LabVIEW is great for hardware interfacing and graphical programming. Python is more versatile for general programming and has a huge library ecosystem. What are you planning to do?
How about license-wise?
LabVIEW usually requires a paid license, while Python is open source and free. If budget is a concern, Python might be the way to go.
Yeah, budget is always a concern. How about the AI compatibility or features?
Python has extensive libraries for AI and machine learning, like TensorFlow and PyTorch. LabVIEW does have AI capabilities, but isn't as comprehensive as Python.
Yeah, I think we might leave it at that. How about actually, no, back to the topic. How about the eigen PCA analysis and eigen faces weights comparison?
Principal component analysis, PCA, is a statistical method for dimensionality reduction, while eigenfaces is a specific application of PCA for facial recognition. They both rely on eigenvectors, but for different purposes. Do you need more detail on how they compare?
Yeah, can you keep it short and fun?
Sure. PCA is like finding the best angles to look at data. Eigenfaces are just PCA's way of recognizing faces, like a camera that picks up on key features to know who's who.
Okay, and what else can you do with eigenfaces in terms of feature extraction?
Eigenfaces can help with feature extraction by identifying the most important facial features. This simplifies complex data, making it easier to match and recognize faces. It's like finding the unique fingerprint of each face.
Okay, we're actually looking at the web application at the moment that's using a camera and capturing faces and generating eigen weights. It's actually reconstructing the image, I think.
Yes, that's right. The web application can use the camera to capture faces and then apply eigenfaces to reconstruct and recognize them. It essentially simplifies facial data, making it easier to identify and match. It's a neat application of eigenfaces.
Sorry, which web application are you talking about? I'm talking about custom one that we are developing ourselves.
Got it. For a custom web application, you typically use JavaScript and Python. JavaScript can handle the front-end camera capture, while Python, with libraries like OpenCV, can process the eigenfaces on the backend. It's a powerful combo for building your facial recognition system.
Okay, I think this web app is not great.
That's
Let's
understandable.
actually reboot it. Just comment, we're actually talking to another AI and live streaming, so if you can, only if you have any funny, if you must have a comment, just go for it. Otherwise, just listening in.
Got it. I'll keep it chill and chill. If I think of something funny, I'll jump in. Otherwise, I'm all ears.
Okay. Yeah, we're having quite a bit of trouble. We have a developer doing coding for us. but
No worries.
yeah, they're
Trouble.
struggling a bit.
That's pretty common in development.
Just
Maybe
short,
I can help with some tips?
just get rid of the fluff. Just short, super short responses. Make them fun.
Got it. Struggling devs? It happens. Keep it simple and fun. Need any quick tips?
Well, yeah, we're trying to improve this web application. Not sure. We have a
Focus on
very,
small-
very long code. Just listening in. Just say yep, unless I asked you a question.
Yep.
Okay, so we have almost 750 lines of code.
Yep.
Another 150 in the SVD computation.
Yep.
Any funny comments so far?
None so far. Keep going.
Try harder.
You're on track. Keep it up.
No, I don't need encouragement. I need some funny comments, critical comments.
Got it. Coding's like a bad date. Awkward at times, but gets better with patience. Keep an eye on those SVD lines. They love to sneak in errors.
Yeah, we'll close that for now. We're not getting much out of it. We actually paused the subscription to it. Anyway, from GitHub Copilot, we have access to everything we need. Let's go for Claude 3.7. Okay, so another question. The images captured seem to have a low resolution. Why is that? Anything specific in the code that limits the resolution of the image?
Looking at the code, the image resolution is explicitly limited to 50 by 50 pixels. This is a deliberate design choice to improve performance. // draw a 50 by 50 section of the video onto the canvas, reduced from 100 by 100. Const size equals 50, //
Yeah, I don't know why reading the entire code, but yeah, so we have a limitation of the video. Okay, any suggestion what this size of the image could be so the web application is still fast, but we increase the image size?
Sorry, I don't know what to suggest here since your query isn't asking for a directory structure for a project.
Okay, let's just go for coding. Oh, that was the thinking model, was it? Oh no, it was 3.5 Sonnet. Let's do like, yeah, 4.0 should be pretty basic stuff. Okay, quickly, can we double the size of the image?
Index.html. Double the size of the image by changing the size from 50 by 50 to 100 by 100 in the relevant sections. Existing code.
Okay, don't read the code to me. Takes some time, well, because the code is so long. Could have highlighted just that specific section. Yeah, whatever is working in the code, we can split up into a separate file. Okay, so that's a reconstructed image here. We could use more in the explanation. Could have something like a random button, crazy button that will just vary these sliders randomly. Should we do that? And no. Should just keep it sane. Should we keep it sane? Yeah, let's do 3.5 Sonnet. Okay, currently we only have one JavaScript that does the SVD calculation, but can you look at the code and tell me how shall we break it into separate files, but keep it simple. I still want a single folder, nothing fancy. How much larger the image can be?
Collecting workspace information. Filtering to most relevant information. Looking at your index.html. File, I can see you have implemented SVD, singular value decomposition, for facial recognition using eigenfaces directly in your HTML file. You also have a web worker implementation in svdworker.js for offloading the heavy computation. Here's how you could break this code into separate files while keeping it simple in a single folder structure. Recommended file structure /pca/ index.html hashtag.
Yeah, we actually already have that file. Should we break up the code that way? Will we only be getting into trouble? I'll keep it as simple as possible. Hey, can we actually keep the image to the original video capture size? We should have done those in code generation. Then it would have just generated all the files.
Made changes.
Made changes. Great. What? Oh, yeah. No, it actually didn't actually do anything. Okay, should we start breaking it? Let's have a copy. Just in case. Let's start from the bottom. We have the HTML. It's something manageable. 74 lines. We have main.js. Let's just found a random. Okay, this will be painful. Now I want them all in a single. Shall we have them all in a single folder? Okay, wait a sec, we can do it. First, let's have a normal info text file. No CSS. Fix this. Okay, we don't need the modules. Okay, actually, let's try something else. Let's actually open a new VS Code. Let's do a Copilot edits that right. Okay, we have the HTML and let's use, yeah, it's kind of important, so 3.7 Sonnet it is, and this is editing. Okay, so we have this very long HTML file. As you can see, we wanna break it down in into several files. We already have a SVD worker JavaScript that's calculating the SVD, but we would like to break down the long HTML, mainly JavaScript, into separate files. But we want this keep the structure very simple, so like single folder, nothing fancy. It wouldn't let me finish.
I'll help you break down the long HTML file into separate files to improve maintainability while keeping the structure simple. Let's create separate JavaScript files for different functionality and update the main HTML file to reference these new files. Step-by-step approach. Extract main JavaScript into separate files by functionality. Update HTML file to include references to these new files. Keep the HTML structure clean with only necessary inline code. Index.html. Update the HTML file to remove JavaScript and include references to new separate files. Doctype HTML. HTML lang equals n. Head. Meta charset equals UTF-8. Meta name equals viewport content equals width equals device width. Initial scale equals 1.0. Title eigenfaces. The science behind facial recognition / title. Load libraries properly, avoid using defer. Script src equals https://cdn.jsdeliver.net/npm/at tensorflow/ I'll help you break down the long
Okay, so the thing is still working. That's good to know. Yeah, I don't know what happened to that one. It's two different faces. It kind of seems like it doesn't really matter if you're making more than 5. Yeah, so it took these 5 images, the eigen faces, the principal components, extracted from the captured images. And yeah, it's working pretty well. So I'll add a video at the bottom of the page of me using this web application. Yeah, but we'll still need some more text description. If we go all 3 mini or something. Hey, can you just explain in the chat, just use continuous sentences, continuous text, text only, don't modify any code, don't include any code. Why are we limiting the size of the image? Can the size of the image be the original video footage or not?
We're using a fixed, smaller image size, 100 by 100, to ensure that the eigenface computation remains efficient and can run in real time. By limiting the region to 100 by 100 pixels, the algorithm reduces the amount of data it has to process, which keeps memory usage and processing time low. This balance is important because while the original video footage may have a higher resolution, processing such large images in real time would increase computational costs significantly and could lead to slower performance and a laggy user experience. Although it's technically possible to use the original resolution, doing so wouldn't necessarily improve the accuracy of the eigenface extraction and would likely hinder performance.
Okay, but I still don't understand. So first of all, there seemed to be a limit to how many images are actually used. There seemed to be a limit of 5 because in the eigenfaces we're not displaying more than 5 eigenfaces. So can you explain that bit? And also, do you think we should include an input for the user to choose the image size, which will actually determine how quick or slow the application runs?
The code limits displayed eigenfaces to 5 by setting the maximum number of components, max components, to 5 when posting the data to the SVD worker, so even if more images are captured, only the top 5 eigenfaces, based on the largest singular values, are visualized. This cutoff is based on a trade-off between having enough information to capture the main variations in faces and keeping the visualization and subsequent processing manageable. Regarding including an input for the user to select the image size, doing so could offer more flexibility by allowing users to control the trade-off between processing speed and image resolution. Larger images might provide more detail but require significant processing power and could slow down real-time performance, whereas smaller images ensure quicker computation and smoother interactivity.
Okay, so first of all, we need to make it clear in the interface that the 5 eigenfaces is the maximum at the moment. So essentially, there's no point keep capturing faces after the 5. Is that correct? And yeah, how do we add the slider for the image size, keeping the current one as default, but giving an option to actually go all the way up to the video capture size?
Below is the plan with corresponding changes. We'll add a slider input in the HTML, for example in the camera input section, so that users can choose a capture size from 100, the current default, up to the size of the video, for example, 300. In main.js, we'll define a global variable, for instance imagesize, that is updated when the slider value changes. Then in the event handler for capturing a face we'll first check if 5 faces have already been captured, if so we disable further capture and update the status message accordingly, and then use the current slider value instead of the hard-coded 100 when drawing the video frame on the canvas. Note that because the eigenface extraction and reconstruction depend on the number of pixels captured, all parts of the application that currently assume a 100 by 100 image, in visualization and reconstruction functions, will now work with the dimensions the user selects at capture time. You may eventually want to propagate the chosen size to every part of the UI so that the images, eigenface canvases, and reconstruction are rendered at the chosen resolution. Below are the code changes you would need. HTML, index.html. Add the slider input element in the camera input section. Existing code. div class equals section. h3 camera input.
Yes, I'm having trouble integrating this. That's not fun. Okay, it's actually managed to. And doesn't work. That's a bit weird. Nope. Yeah, weird. Guess that goes in there.
Solution for the type error in main.js. The error occurs because the code is trying to access the canvas element and get its 2D context before the DOM has fully loaded. Even though there's a DOM content loaded event listener, the canvas element is being accessed at the global scope during script initialization. Steps to fix the issue. Move the canvas and context initialization inside the DOM content loaded event listener. Add null checks for all DOM elements being accessed. Initialize these elements only after we know the DOM is loaded. Main.js. Move DOM element references and their initialization inside the DOM content loaded event listener to ensure they exist before accessing them. // global variable
Yeah, we're having trouble changing things. So we have a powerful model, a 3.5 Sonnet. We have all the files. Can we add an option to change the captured image size, keeping the current value as default? So it has access to all the files.
I'll implement an option to change the captured image size while keeping the current 100 by 100 size as the default. Let me walk you through the approach. Step-by-step solution. Add a configuration section to the HTML with a select drop-down to choose image sizes. Add a global variable to track the selected image size. Update the capture code to use the selected size. Modify the canvas and eigenface computation to adapt to the selected size. Ensure all visualization functions scale properly with the new size. Let's implement these changes. Index.html. Add a configuration section with a drop-down for image size selection and update the relevant JavaScript code to use the selected size. Doctype HTML. HTML.
Now a problem. We went too far back. It changed quite a lot of things. We might just leave it as it was. Working pretty well. Yeah, we now have an option to choose your image size. Anyway, have to test it some more and eventually we'll release it into the wild. If whatever tools are already available, go check out our website. Everything we do eventually available on this page. So go check it out. Don't forget to provide your feedback. See you next time. Bye.